Imagine standing beneath a night sky so vast, so piercingly silent, that it feels as though the universe itself is holding its breath. Stars shimmer like distant memories, galaxies swirl like ancient ghosts, and the blackness between them stretches out like an infinite ocean. At first glance, it appears peaceful, majestic, even comforting. But the deeper you look, the stranger it becomes. Those shimmering lights are moving away from us. The very fabric of space is stretching. And the farther we peer, the more the universe resembles not a serene cosmic meadow, but something far more mysterious, something far more terrifying. For centuries, we've tried to understand the universe using logic, mathematics, observation, and imagination. We mapped stars, measured cosmic distances, decoded light, and built theories that expanded our view of reality. But with every answer came a darker, more unsettling possibility. What if the universe is not open and free? What if it is not endless, not boundless, not expanding into some majestic infinite playground? What if everything we know, every galaxy, every planet, every moment of time, is actually unfolding inside a colossal cosmic trap? Consider the strange behavior of spacetime itself. Light bends when it passes near a massive object. Time slows down when gravity becomes strong. Near the edge of a black hole, these effects become so extreme that they stretch reality into forms that defy intuition. A soul approaching the event horizon, the ultimate point of no return, would see time distort, freeze, and warp into bizarre, almost dreamlike patterns. Space would curve inward like a cosmic whirlpool. The rules of physics would begin to twist into something unfamiliar. And yet, from the perspective of the falling observer, everything would seem normal, ordinary, unremarkable. The descent would be almost peaceful. Now think about our universe. Think about how galaxies appear to be rushing away from each other, not because they're moving through space, but because space itself is expanding. Think about how time flows differently depending on where you are in the cosmos. Think about the mysterious force we call dark energy, an invisible pressure that seems to push everything outward, accelerating the universe's growth with a quiet, relentless insistence. These are not surface-level quirks. They are deep, structural features of our reality. And disturbingly, they mirror the physics that would be experienced inside a black hole. Imagine, for a moment, that the Big Bang wasn't an explosion in the traditional sense. Imagine it instead as the moment an unimaginably massive star in some parent universe collapsed under its own weight. Gravity crushed its core into a singularity, a point of infinite density. Space tore open. Time folded inward. And on the other side of that collapse, a new universe was born. Our universe. The one we live in. The one we think is independent and free. But what if it is not? What if we are merely the interior of that collapse, expanding from an initial point not outward into a void, but downward into a deeper gravitational well that we can never escape? The question is unsettling because it challenges everything we believe about existence. We grow up imagining the universe as all there is, a kind of cosmic container holding everything from atoms to galaxies to consciousness itself. But what if the container has walls? What if the boundary around our universe, the cosmic horizon we can never cross, is not an edge of space but the event horizon of a black hole? A horizon that traps light, information, and time. A horizon that defines our existence not by freedom but by confinement. And what if the expansion of the universe is not a journey outward, but a journey inward? When a black hole forms, spacetime stretches violently, pulling everything toward the center. To an outside observer, falling objects appear frozen at the horizon. But inside, the space opens into something that feels infinite. Something that can hold galaxies. Something that could last billions of years. From the inside, the fall feels like creation. From the outside, it looks like destruction. Two opposing truths woven into the same cosmic event. This contrast, creation versus collapse, freedom versus confinement, forms the heart of the mystery. Are we living in a universe shaped by expansion, or are we drifting down a gravitational waterfall so immense we cannot perceive its edges? If the laws of physics inside a black hole mimic the laws of physics in our universe, then how would we know the difference? If time slows, if space stretches, if horizons form, if information is trapped, these are not distant astronomical curiosities. These are the very conditions of our existence. And then comes the most haunting possibility of all. What if we were never meant to know? What if the universe is designed in such a way that the truth about its nature is mathematically, physically, fundamentally unreachable? Every direction we look, every telescope we build, every particle we collide, every theory we propose, brings us closer to the horizon but never through it. We see only the inside. We measure only the effects. We are like fish swimming in the depths of an ocean, staring upward at a shimmering surface we cannot break. Yet the question remains, whispering through the silence of the cosmos. Are we truly free in an expanding universe, or merely falling deeper into a cosmic abyss too vast for our minds to grasp? Is our reality the product of a grand beginning, or simply the interior of something collapsing? The sky above us may not be a window into infinite space, but a ceiling curved by gravity and shaped by forces we cannot escape. And if that is true, then the universe is not just a home. It is a mystery. A trap. A question waiting to be answered. And the most terrifying part is this. Maybe the universe already knows the answer, but we are not yet ready to hear it. There is a strange kind of darkness that lives at the edge of everything we can see. It is not the familiar darkness of night or the shadow cast by a passing cloud. It is older, deeper, more absolute. It is the darkness of distances so enormous that light, traveling at the fastest speed allowed by the laws of nature, has not yet had enough time to reach us. We call this the cosmic horizon. But the name does not capture its true power. It is more than a boundary. It is a wall of ignorance, a silent perimeter marking the end of our visible universe. Imagine standing at the shoreline of an endless ocean at midnight. You can feel the waves at your feet, hear the wind, taste the salt in the air. But beyond a certain distance, the water dissolves into blackness. You know the ocean stretches far beyond what you can see, but the darkness hides its scale, its secrets, its creatures. The universe is the same. We see galaxies, hundreds of billions of them, floating like jeweled islands on an invisible sea. But beyond a certain limit, everything fades into a cold, impenetrable void. The strange part is not that the universe has a horizon. The strange part is why it has one. The universe is expanding. Every moment, every second, every heartbeat, space stretches a little more. Distant galaxies are being carried away from us by this expansion, faster and faster, until eventually the light they emit cannot outrun the stretching of spacetime. Their glow becomes trapped behind a curtain of cosmic darkness, forever out of reach. This horizon is not fixed. It is not a line we can travel toward or a border we can cross. It is a moving, shifting limit defined by the speed of light and the pace at which the universe expands. Anything beyond it becomes invisible, undetectable, unknowable. It is a universe inside a universe, a bubble drifting through a larger reality we can never touch. And this raises a haunting question. If we can only see a tiny fraction of what exists, how do we know the universe is what we think it is? The deeper scientists study this darkness, the more unsettling the picture becomes. As the universe expands, more and more galaxies drift beyond our reach. The night sky grows emptier. The cosmic stage is getting quieter, lonelier, more desolate. In a distant future, perhaps only one galaxy will remain visible. Everything else will slip beyond the horizon, erased from the observable universe as if it never existed. This is not poetic exaggeration, it is physics. The universe we know is shrinking, and yet it continues to grow. Now imagine the perspective of someone living inside a black hole. To an external observer, the boundary of the black hole, the event horizon, is a place of no return. Nothing escapes it, not even light. But inside, the spacetime geometry changes. Volumes stretch in ways that mimic cosmic expansion. Light curves. Time dilates. The interior can appear vast, enormous, almost infinite to anyone falling within it. To them, the horizon is not a visible boundary, it is simply the limit of what can be observed. They live inside a shadow wrapped in spacetime. This eerie similarity has caused physicists to wonder whether the horizon of our universe and the horizon of a black hole might be two versions of the same phenomenon. The universe appears to be wrapped in an invisible shell that prevents us from seeing beyond it. A black hole is wrapped in an invisible shell that prevents anything from escaping it. And both horizons move in ways that depend on the underlying geometry of spacetime. If the universe truly behaves like the interior of a black hole, then the darkness we see at its edge is not the darkness of emptiness, it is the darkness of a cosmic boundary. Trap. A limit placed upon us by forces woven into the fabric of reality long before the first stars ignited. But even within this shadowy confinement, there is something profoundly beautiful. Every galaxy we see is drifting not through empty space, but through a sea of invisible structures. Dark matter forms colossal skeletons that stretch across the universe, shaping the cosmic web. Dark energy, the mysterious force pushing galaxies apart, acts like a silent wind, accelerating everything outward with a steady, almost ghostly pressure. These forces, though invisible, carve the universe into patterns so intricate they resemble veins, tendrils, arteries of light and matter. And yet, the deeper we look into this structure, the more it resembles the gravitational geometry predicted inside a black hole. Regions fold away from us, not because space ends, but because the horizon hides what lies beyond. Light is stretched, distorted, reddened until it fades. Time behaves differently at greater distances. The universe itself seems to warp under the weight of something immense, something we cannot see but can feel through its effects. Try to imagine this. Every night when you look up at the sky, you are gazing at a tiny window carved into a much larger, unreachable reality. You are seeing the interior of a cosmic chamber whose true shape you may never grasp. The horizon is not the end of space, it is the limit of revelation. A wall not made of matter or energy, but of the rules that govern our existence. And beyond that wall could lie anything. Infinite space, a parent universe, a sea of other universes, or the outer structure of a black hole far larger than our imagination can comprehend. This creates a profound emotional contrast. On one hand, the universe appears infinite, majestic, overflowing with worlds and wonders. On the other hand, it may be bounded, trapped, sealed off inside an invisible sphere. We swing between awe and dread, between wonder and confinement. We are explorers standing at the edge of a cosmic shore, aware that the ocean stretches far beyond our sight but unable to sail past the darkness. Yet perhaps the most haunting truth is this: the horizon is not merely out there, it is inside the physics that shapes our lives. We are part of the mystery. Our atoms were forged in stars, our bodies shaped by gravitational battles that unfolded billions of years ago. We live in a universe built from the ashes of cosmic collapse. And the horizon is a reminder that no matter how much we learn, the universe will always guard some secrets behind an impenetrable veil. What lies beyond that veil remains unknown. But the darkness at the edge of our vision is not empty. It is waiting. It is watching. And it may hold the key to understanding whether we inhabit a universe of endless possibility, or the interior of a titanic cosmic shadow. Long before humans learned to read the heavens, before telescopes, before mathematics, before the very idea of science existed, stars were already living out their ancient, violent destinies. These massive, burning spheres, colossal furnaces of hydrogen and helium, shine for millions or even billions of years. But every star carries a secret written into its core, a secret it cannot escape. Eventually it must die. And when a truly massive star meets its end, the universe witnesses one of the most destructive and awe-inspiring events nature can create, a collapse so intense it rips spacetime apart and gives birth to a black hole. Imagine a star dozens of times heavier than our sun. For millions of years, it has fought a delicate balance. Gravity pulls inward, trying to crush the star under its own weight, while nuclear fusion pushes outward, generating light and heat that counter gravity's relentless pull. This balance is fragile, almost poetic. But nothing lasts forever. One day the star's fuel begins to run out. Fusion slows. The outward pressure weakens. Gravity senses the opportunity and begins to tighten its grip. Picture the moment when the last of the nuclear reactions sputter and fade. The core of the star, no longer supported, collapses inward with unimaginable force. In the span of a second, matter is crushed to densities so extreme that atoms themselves cannot survive. Protons and electrons slam together and merge into neutrons, releasing a cascade of energy that triggers a supernova, an explosion so bright it can outshine entire galaxies. But the supernova is just the visible drama. The real story is unfolding inside the collapsing core, deep beneath the blinding flash. Gravity continues to pull inward, refusing to be stopped. Neutrons are squeezed tighter and tighter until even they cannot resist. The collapse accelerates. Space folds inward. Time distorts. The core shrinks past the scale of atoms, past the scale of subatomic particles into something smaller, denser, stranger. A point where all known physics breaks down. A point of infinite density. A singularity. This is the birth cry of a black hole. If you could watch this moment from a safe distance, far enough not to be consumed by the gravitational fury, you would see something unreal. The star's outer layers explode outward, forming a brilliant supernova remnant. But the core, now a black hole, begins to warp the space around it. Light bends. Time slows. Anything that drifts too close spirals inward like a leaf caught in a whirlpool. But there is a deeper mystery hidden in this collapse, one that scientists are only beginning to understand. The mathematics describing a black hole's formation resembles the mathematics describing the early expansion of our universe. The way spacetime curves around a singularity resembles, in eerie detail, the way it expanded in the moments after the Big Bang. These similarities raise a haunting possibility. What if the Big Bang and a black hole birth are not two different events, but but two sides of the same cosmic process? To understand this, imagine the collapsing star from the inside. As the core contracts, spacetime curves inward so violently that directions themselves begin to lose meaning. Down becomes deeper gravitational pull. Outward becomes impossible. Space is dragged faster than anything can escape. And yet, from within this collapsing space, a strange thing happens. The interior suddenly feels as though it is expanding. Not outward into the universe we know, but into a new, internal dimension. Now imagine this expansion continuing, not for seconds but for billions of years. The inside of the collapsing core feels like a growing universe. Galaxies could form. Stars could ignite. Life could emerge. From the outside, the black hole appears small, dense, and doomed to collapse. But from the inside there could be a vast, expanding cosmos. Sound familiar? Our universe, too, began with a moment of violent compression followed by rapid expansion. Our universe, too, has a horizon beyond which nothing can be seen. Our universe, too, contains a pervasive gravitational pull that shapes the motion of stars, galaxies, and cosmic structures. If black holes can create new universes inside their singularities, then perhaps our universe is itself the interior of a black hole born in some larger, older cosmos. But the birth of a black hole is not only about crushing matter, it is about rewriting reality. As the star collapses, spacetime doesn't simply warp, it is dragged inward like fabric being pulled through a hole. The event horizon, the boundary of no return, forms like a membrane around the new cosmic infant. This horizon is more than a gravitational boundary. It is a barrier between two worlds, the outside universe where time and space follow familiar rules, and the inside, where the laws of physics become unrecognizable. Inside, space stretches. Time distorts. Paths converge toward the singularity but may also expand into new regions of spacetime unreachable from the outside. This interior could theoretically contain enough room to hold entire galaxies. The scale mismatch is staggering. A black hole only kilometers across could have an internal volume larger than the observable universe. This paradox, small on the outside, enormous on the inside, is one of the most haunting clues linking black holes to cosmic creation. But perhaps the most chilling image of all is the singularity itself. It is a place where matter is compressed to infinite density, where spacetime curves infinitely, where the known laws of physics fail. A place where the familiar concepts of distance, direction, and time collapse into a single, incomprehensible point. Some physicists think the singularity may not be a real place at all, but a sign that our understanding of gravity is incomplete. Others believe it may be a bridge to another region of spacetime, a gateway, a birth canal, a cosmic seed. And then there is the question of information. When a star collapses into a black hole, does all the information about its structure, its atoms, its particles, its history disappear? Or does the universe store this information on the event horizon like a cosmic hard drive? If information is preserved, then a black hole might contain the blueprint of the universe it creates. A universe that inherits the properties of its parent star. A universe with physical laws shaped by the geometry of its birth. Imagine that for a moment, every black hole in the cosmos could be a womb. Every collapsing star could be the first moment of another reality. Every singularity could be a beginning disguised as an ending. And if that is true, then the birth of a black hole is not just a violent end to a star, it is the quiet, unseen beginning of an entirely new universe. A universe that might, somewhere within it, produce stars, planets, life, and beings just like us, wondering where they came from and whether they, too, are living inside the aftermath of a collapse. If the universe is a chain of generations, a lineage of cosmic births, then our existence may not be the result of a single Big Bang, but the continuation of an ancient, endless cycle of collapsing stars giving rise to new realities. And hidden within this possibility lies a profound question. If black holes create universes, then what created the black hole we live inside, and what existed before it? The answer, for now, lies somewhere deep in the darkness where stars collapse and new universes are born. To understand how our universe might exist inside a black hole, we must confront a strange and counterintuitive idea. From the inside, a black hole does not look like a trap. It looks like a world. Not a crushing void, not an inescapable cage of darkness, but an entire spacetime, stretching, bending, expanding as though it were born to mimic a universe. This idea is so bizarre that it challenges even the most experienced physicists. Yet the mathematics keeps pointing back to the same unsettling conclusion. The interior of a black hole behaves almost exactly like the expanding cosmos we live in. Imagine falling toward a black hole. At first, everything seems familiar. Stars in the distance, space humming with silent emptiness. But slowly, almost imperceptibly, the world begins to distort. Light bends around you in ways that defy intuition. Time seems to slip, stretching thin in front of your eyes. As you get closer, you would expect fear, panic, the primal instinct to escape. But something else happens. The boundary you feared, the event horizon, doesn't appear as a physical barrier or a glowing ring of doom. It simply arrives. You cross it without noticing. No flash. No impact. No warning. Inside, everything changes. The rules you once trusted begin to unravel. Space no longer behaves like the calm, obedient stage you've always known. Instead, it stretches in unexpected directions. The inward pull toward the singularity feels less like falling and more like being carried along by a river that has no surface, no banks, no floor. The horizon you crossed cannot be seen behind you. It is gone, hidden forever by the curvature of spacetime. What was once outside is no longer reachable. There is only forward into a domain where space stretches even as it collapses. Now imagine that instead of falling alone, you are falling with an entire universe. Galaxies, planets, stars, clouds of dust, pockets of dark matter, everything drifting together inside this expanding interior. To the beings living inside, the fall doesn't feel like a fall at all. It feels like cosmic expansion. It feels like the universe itself is getting bigger. If you tried to measure the distances between galaxies, you would find them increasing. If you studied the light from distant regions, you would see it stretched, reddened, exhausted by the growing space between you and its origin. If you built theories to explain this motion, you would invent concepts like dark energy, cosmic inflation, and the accelerating expansion of space. And yet, all of this would be happening inside the curved, inward-folding geometry of a black hole. At first, this seems impossible. How could something that collapses inward create the illusion of expansion? But this contradiction dissolves when we consider a powerful truth: perspective matters. From the outside, a black hole appears to shrink everything to a point. From the inside, spacetime can stretch outward indefinitely. The collapse creates the expansion. The singularity births the universe. Two opposing realities, both true depending on where you stand. Picture spacetime as a sheet of rubber. A massive star collapses, pulling the sheet downward. From above, the depression looks like a hole. But inside the depression, the sheet curves into a new shape, a valley that can feel wide, spacious, even boundless. If you lived inside that valley, you would think you were inside an expanding world. You would see no edges, no exterior, just an endless landscape carved by gravity. This idea becomes even stranger when we consider the flow of time. Outside a black hole, time slows near the event horizon. A falling object appears to freeze, suspended forever at the edge. But from the inside, time moves normally. Your seconds tick by with familiar rhythm. Your life unfolds at its usual pace. Meanwhile, from the outside, the entire lifetime of the universe might pass before you ever reach the singularity. Now take that concept and apply it to our cosmos. To us, the universe appears to be nearly 14 billion years old. But if we are inside a black hole, the outside observer might see our entire cosmic history unfold almost instantly, compressed into the blink of an eye. Our billions of years could be someone else's seconds. Our infinite stars could be the quiet interior of a collapsing core. This duality becomes even more haunting when we look at the shape of our universe. Cosmic measurements show something strange. Space is flat. Perfectly, eerily flat. Not curved like a sphere. Not saddle-shaped. Completely flat, as though stretched tight across some hidden boundary. This flatness is exactly what the interior of a black hole would look like if spacetime stretched fast enough. Our universe's expansion rate, the exact speed at which galaxies drift apart, matches the theoretical stretching inside a black hole almost perfectly. Even the temperature of the universe adds to the evidence. The cosmic microwave background, the faint afterglow of the Big Bang, is almost uniform across the sky, differing only by fractions of a degree. This level of uniformity would require regions of space to have communicated long before light had enough time to travel between them, unless they were originally packed incredibly close together in a collapsing star, pressed into unity by gravity before expanding into the cosmos we now observe. Then comes the most astonishing clue. The universe has a maximum speed limit. Nothing can move faster than light. Not because of some arbitrary rule, but because spacetime itself is shaped to prevent it. Inside a black hole, the same rule applies. Light cannot escape the curvature. It is bound to stay inside the horizon, trapped in the geometry of the interior. Our universe behaves as though we, too, are inside a region where light cannot leave, where light is confined by the structure of spacetime itself. But perhaps the most chilling similarity is the presence of a boundary we can never cross. The cosmic horizon. The edge of the observable universe. Not an end of space but a limit on what we can ever know. A limit that expands as we expand. A limit that behaves exactly like the inner surface of a black hole's event horizon. Now imagine the implications. If our universe is the interior of a black hole, then every black hole in our universe might contain another universe. A branching tree of realities, each born from the collapse of massive stars in parent universes. A cosmic family tree stretching backward and forward through eternity. And this raises the final, unsettling question. If we are inside a black hole, then somewhere outside our universe, far beyond our horizon, there may exist a parent star that collapsed billions of years ago. A star in a larger cosmos. A cosmos with its own galaxies, its own physics, its own observers who may never know that inside one of their ancient stars, a universe is unfolding. A universe with its own stars, its own galaxies, its own beings who look up at their skies and wonder where everything came from. And if they, too, have black holes, then inside those black holes, more universes may be expanding. If the universe is a chain of cosmic wombs, then existence is not a single story but an infinite branching of realities, each born from collapse, each ending in collapse, each passing the seed of creation onward. And somewhere within this endless lineage we exist, inhabiting a universe that may be nothing more than the interior of a collapsing star in a world we will never see. The story of our universe is usually told as a grand explosion, the Big Bang. We imagine a singular moment of creation, an instant when all matter, energy, and space erupted outward from an incomprehensibly dense point. It is a vision that feels dramatic, almost cinematic, fire, light, and chaos giving birth to everything we know. Yet, what if this narrative is incomplete? What if the Big Bang was not a beginning in the conventional sense but something far stranger, part of a repeating cosmic rhythm, a big bounce, that echoes through space and time? Picture a universe collapsing. Imagine all galaxies, all stars, all cosmic matter slowly drawn together by an unstoppable gravitational pull. The universe contracts, compressing matter into tighter and tighter bounds. Time, space, and energy spiral inward, pulled into a singularity so dense and extreme that conventional physics can no longer describe it. This is not merely a thought experiment, it is a concept rooted in the equations of general relativity and quantum mechanics. Some physicists suggest that the Big Bang itself could have emerged from such a collapse, a universe bouncing back after imploding, giving rise to the cosmos we now inhabit. The imagery is staggering. Imagine standing on a cosmic shore, watching the universe shrink into itself. Galaxies spiral together, colliding, merging, and vanishing into an incomprehensible core. The sky becomes dense with energy. Light bends in impossible arcs. The very fabric of reality trembles under the weight of compression. Then, in a moment we can scarcely imagine, everything reverses. The singularity, the point of ultimate collapse, becomes the seed of expansion. Matter bursts outward. Space inflates. Time unfolds again. A new universe emerges, carrying echoes of its predecessor, and perhaps even a blueprint of its laws. This idea of a cosmic bounce introduces a striking contrast between destruction and creation, between endings and beginnings. Collapse is usually associated with loss, with finality, with despair. Expansion, by contrast, evokes hope, growth, and the promise of life. In the Big Bounce scenario, these opposites are inseparable. The end of one universe becomes the beginning of another. Death births life. Oblivion gives rise to infinity. The act of imploding is simultaneously the act of creating, a duality that both terrifies and fascinates. Such a concept forces us to rethink the nature of time itself. We are accustomed to seeing time as linear, past, present, future. But in a bouncing universe, time may be cyclical, repeating across eons. Every contraction followed by expansion is a rhythm, a heartbeat in the life of existence. Past and future blend. Endings are beginnings. Our universe, with its stars and galaxies, may simply be the current note in an eternal symphony of cosmic collapses and rebirths. The possibility of a big bounce also reframes our understanding of black holes. If collapsing stars can give rise to new universes, then perhaps collapsing universes can, in turn, ignite the birth of larger, more expansive realities. Each implosion is both an ending and a seed for creation. Each singularity carries potential, hidden and unseen, awaiting the moment when space and time can unfold again. Our own universe could be the offspring of such a cosmic parent, a universe born not from nothing but from the collapse of another. Consider the physical evidence that supports this idea. The early universe appears to have been incredibly uniform, yet sprinkled with slight irregularities. These tiny variations, hot spots and cold spots in the cosmic microwave background, are precisely what would be expected if the universe had previously contracted and then rebounded. In a collapsing phase, regions of matter would have been pressed together, smoothed by gravitational forces, and then carried outward in the expansion. The resulting pattern of cosmic density variations matches what we observe today. It is a subtle fingerprint of collapse hidden in plain sight. The emotional weight of this possibility is profound. We tend to think of the universe as a one-time creation, an isolated event that defines existence. But if the cosmos is bouncing, then our reality is part of an infinite cycle. The universe is not static. It is not finished. Every collapse is a prelude. Every expansion is a continuation. Human history, fleeting though it may seem, unfolds against a backdrop of cycles that stretch beyond comprehension. In the vast, unfeeling rhythms of cosmic contraction and expansion, we exist like sparks in a grand, eternal fire. And the philosophical implications are staggering. If our universe is part of a continuous series of bounces, then questions of origin, where did it all come from? Become different. Perhaps there was never a true beginning, only an eternal chain of transformations. Perhaps time itself is a circle, not a line. Perhaps the universe is infinite not because it has no edges, but because it has no beginning or end. The Big Bang becomes not a singularity of creation, but a moment in a much larger, ongoing process. Yet the Big Bounce also introduces tension and mystery. If the universe is cyclic, then why do we experience it as beginning at a specific point? Why do we perceive the passage of time as flowing forward, from past to future, from creation to entropy? Could it be that our perception is tied to our position within a single expansion phase, blind to the contraction that preceded it? The universe could have been bouncing long before life ever emerged on Earth, its rhythms hidden in the deep structure of spacetime, inaccessible to our senses, yet encoded in the geometry and behavior of the cosmos. From a cinematic perspective, the imagery is awe-inspiring. Picture a contracting universe as a swirling maelstrom of galaxies, spiraling inward like water down a cosmic drain. Light bends and twists as it falls toward the central singularity. Stars collide, explode and vanish, creating a symphony of destruction and beauty. Then with sudden grace the collapse reverses. Matter erupts outward. Time unfolds like a film rewinding, then playing forward in a new direction. Space inflates. Galaxies form. Planets spin into existence. A new universe emerges, born from the ashes of the old, simultaneously familiar and alien. This vision of a bouncing cosmos unites the terrifying and the beautiful, the destructive and the creative. It asks us to hold two truths at once, that the universe is violent, relentless, and destructive, and that it is also capable of endless creation, resilience, and rebirth. It challenges our intuition, our philosophy, and our understanding of existence itself. It evokes fear and wonder in equal measure, forcing us to confront the limits of what we know and imagine what lies beyond. Ultimately, the Big Bounce forces a confrontation with mystery. The universe we observe, vast and expanding, may carry within it the imprint of a previous contraction. Every galaxy, every star, every particle could be a remnant of an earlier universe, rebounding from the collapse of a parent cosmos. And within this idea lies a paradoxical hope, that even in destruction there is continuity, even in endings there is a beginning, and even in the darkest collapses, a new universe may emerge, carrying forward the spark of existence into eternity. To grasp the true nature of a universe that might exist inside a black hole, we must visualize spacetime not as a flat, static canvas, but as a living, breathing river, curving, stretching, and flowing with an invisible current. Imagine yourself standing beside this cosmic waterfall. Its surface shimmers with light from distant galaxies, yet beneath the surface, spacetime itself is moving, twisting, dragging everything within it along an inexorable path. The flow is invisible, but its effects are undeniable. Objects move not because of propulsion, but because the fabric of the universe guides them. Gravity in this sense is the river. Matter and light are carried along its currents. The scenery is breathtaking, but it is also terrifying. It is impossible to resist. Picture a star drifting too close to the edge of this cosmic waterfall, a black hole. At first it seems normal. Its orbit is predictable. Its light reaches distant observers with ease. But as it approaches the threshold, the river's current grows stronger, faster, unstoppable. The star begins to stretch, elongate, and warp. To any outside observer, It slows, frozen almost in time as if trapped in a viscous, invisible liquid. But from the star's own frame, the journey feels normal, even serene. The surrounding universe curves, bends, and warps, yet the star experiences a continuous flow, its path guided by spacetime itself. This is not metaphor, it is the precise way Einstein described gravity, as the curvature of spacetime dictating the motion of objects. Now expand this image to encompass an entire universe. Imagine the galaxies we see around us, not merely suspended in space, but drifting along currents shaped by the deep geometry of a black hole interior. The distances between stars and clusters expand not because they move through empty space, but because space itself stretches, flowing outward like water cascading over an unseen edge. This flow is subtle, almost imperceptible at small scales, yet it dominates at the cosmic level, giving rise to the expansion of the universe. It is as if the very fabric of existence carries everything along a river we cannot escape, yet one that appears infinite from within. The waterfall analogy also helps us understand why light behaves so strangely near massive gravitational objects. Photons, the particles of light, travel along the curves of spacetime. Near a black hole, these curves become steep and light can spiral, orbit, or even fall inward, trapped forever by the flow of the river. Yet within this same flow, the interior of the black hole can appear vast, open, and expanding. A tiny, collapsed core on the outside can house a universe of unimaginable scale within, a paradox that challenges every instinct we have about space, size, and direction. This cosmic river does not only stretch space, it stretches time. As we move along its flow, the rhythm of events is altered. Clocks far from massive objects tick normally, but closer to extreme curvature, time slows. Seconds stretch into hours, hours into years. From one perspective, a falling observer seems to freeze forever. From another, the universe moves on without them. The flow of space-time, the river's current, is not uniform. It bends, accelerates, and twists, creating zones where causality itself appears to warp. This is not science fiction. It is the mathematics of general relativity made tangible, a reality that exists in every black hole, in every massive gravitational collapse, and possibly within the very universe we inhabit. Now, consider dark energy, the mysterious force driving the accelerated expansion of our universe. Its nature is still largely unknown, but its effects are unmistakable. Galaxies drift apart at increasing speeds. The fabric of space stretches faster than light can travel across it. This behavior mirrors the interior dynamics of a black hole in fascinating ways. In both cases, the universe behaves as though carried along by a river, an invisible, unstoppable flow that guides everything along predetermined paths. The similarities are uncanny, a confined interior giving the impression of infinite expansion, motion dictated not by objects themselves, but by the geometry of space, time, and gravity. This perspective also provides insight into the idea of horizons, boundaries beyond which nothing can be observed. Just as a waterfall may hide its full depth behind foaming white edges and swirling currents, the cosmic horizon limits what we can see. Beyond it lies a region of spacetime unreachable by light, forever concealed from our instruments and eyes. Yet, within this concealed region, the flow continues. Time unfolds. Matter moves. Galaxies form. Planets spin. Stars ignite. A universe exists, vibrant and active, yet forever hidden from the view of observers trapped within their own horizon. The cinematic imagery of this flow is impossible to ignore. Picture the universe as a river of light and matter, its currents invisible yet absolute. Imagine galaxies spinning gracefully, carried along by spacetime itself, stretching apart as the flow accelerates. Envision cosmic filaments, the vast threads of dark matter and galaxies, aligned like ribbons in a river, forming patterns and structures dictated not by random chance, but by the underlying curvature of the flowing spacetime. The beauty of this image is almost hypnotic, yet it carries an undercurrent of fear. This river is irresistible. No force within the universe can stop its flow. It guides everything toward paths we cannot escape, toward futures we cannot alter. Consider also the scale of this flow. On a small scale, the effects are subtle. Orbits shift, light bends, time slows slightly. But on cosmic scales, the flow dictates the very shape and fate of the universe. It stretches clusters of galaxies across billions of light-years. It guides the motion of cosmic filaments and voids. It may even carry within it the information and seeds for future structures. The universe, in this sense, is alive, not conscious but dynamic, moving along currents set by the deepest laws of physics. To exist inside such a river is to be part of a flowing, living architecture, one that defies human intuition yet governs every particle, star, and galaxy. And yet, despite this inescapable flow, there is a profound paradox. From inside the river, everything appears stable. Time seems to flow normally. Distances appear ordinary. Light behaves as expected over familiar ranges. The motion of galaxies can be measured and predicted. Yet, in reality, all of this motion is dictated by the curvature of spacetime itself. Free will, motion, and expansion are illusions in the sense that they are guided by an invisible geometry. This duality, appearance versus underlying structure, is a theme that resonates throughout cosmology, from the behavior of black holes to the expansion of our own universe. Finally, consider what this means for our understanding of existence. If we are indeed flowing within a river of spacetime, an interior of a black hole, a bubble inside a larger cosmos, then everything we perceive is part of this current. We are not stationary. We are not separate. We are carried along, guided by the curvature of the universe itself. Our lives, our galaxies, our universe's history, all unfold within a flow we can neither halt nor escape. The poetic and terrifying conclusion emerges: to live inside this river is to be part of a cosmic dance, moving inexorably along a path defined not by choice, but by the elegant, unyielding geometry of spacetime. This cinematic vision of a universe as a flowing, expanding river offers both awe and fear. Awe, because it reveals the hidden elegance of spacetime, the subtle beauty of cosmic currents shaping galaxies, stars, and planets. Fear, because it reveals our lack of control, our tiny place within an unstoppable flow, and the possibility that our universe itself may be the interior of a black hole, drifting inexorably along a river we cannot resist or comprehend. One of the most unsettling aspects of the universe is the presence of singularities, points of infinite density where the laws of physics as we know them collapse. At first glance, singularities seem like abstract mathematical curiosities, lines of calculation on a blackboard with no connection to reality. But in truth, they lie at the heart of both black holes and the origins of our universe. They are the hidden engines behind creation, destruction, and the very fabric of spacetime. To stare into a singularity is to confront a boundary of knowledge itself, a place where time, space, and matter lose meaning, leaving behind only mystery. Imagine the core of a collapsing star, shrinking ever inward, its matter compressed into impossibly small volumes. The density grows without limit. Gravity strengthens beyond comprehension. Space itself curves into folds so steep that up and down lose definition. Any observer approaching this singularity would find themselves in a landscape that defies intuition, where straight lines bend into loops and the familiar geometry of Euclid becomes meaningless. Yet, paradoxically, the interior can feel vast. The singularity may occupy an infinitesimal point from the outside, but within its curved spacetime, it can give rise to volumes large enough to host entire universes. The concept is difficult to visualize, yet mathematics suggests it is possible. The collapse contains the potential for expansion. The singularity represents the ultimate contrast, a place of destruction that also contains the seeds of creation. From the outside, it appears absolute and inescapable, a final endpoint for matter and energy. From the inside, it may function as a womb, a focal point from which spacetime unfolds and universes expand. This duality is central to the hypothesis that our universe itself might reside inside a black hole. If the singularity is not merely a point of annihilation but a catalyst for cosmic birth, then every black hole becomes more than a grave, it becomes a birthplace. Consider time near a singularity. In conventional experience, seconds tick predictably, years pass steadily, and causality holds firm. But near a singularity, time warps dramatically. To an outside observer, objects falling toward the singularity appear to slow, frozen in an eternal descent. Yet to the falling observer, time continues normally, moments unfolding in the familiar cadence of experience. This difference in perception is not just theoretical. It is a direct consequence of the curvature of spacetime described by general relativity. The singularity thus embodies both stasis and motion, a paradox in which time both freezes and flows depending on the vantage point. The singularity also challenges our understanding of information. Classical physics suggests that information about matter entering a black hole is lost forever. Quantum mechanics, however, posits that information cannot be destroyed. This leads to one of the most profound mysteries in modern physics, the information paradox. If information survives, encoded perhaps on the event horizon, then the singularity is not a destructive endpoint but a repository, a place where the blueprint of matter, energy, and perhaps even universes is preserved. Within this perspective, a singularity is less an end and more a seed, containing everything that will emerge in the interior expansion of a new universe. Now, imagine scaling this idea up to the size of the cosmos itself. The Big Bang singularity, the point from which our universe appears to have expanded, shares many properties with black hole singularities. Extreme density, infinite curvature, breakdown of known physics. Could it be that the birth of our universe was not a unique event but part of the same phenomena that create black holes elsewhere in a larger parent universe? If so, our singularity was a starting point shaped by collapse, a core from which space, time, matter, and energy flowed outward. The Big Bang may have been the interior of a black hole in a universe we can never observe. The cinematic imagery of this concept is staggering. Picture the moment of a singularity's birth. A star collapses, its light bending into spirals, matter compressed beyond comprehension. Outside, a dark void stretches infinitely. Inside, spacetime unfolds. Galaxies form, stars ignite, planets coalesce. Time flows, light travels, and matter arranges itself into structures that mirror the vast complexity we observe today. A singularity, once feared as the ultimate destructor, becomes the genesis of everything we know. Philosophically, singularities force us to confront our deepest assumptions about existence. We tend to think in terms of beginnings and ends, cause and effect, finite dimensions and linear time. Singularities dissolve these notions. They suggest that creation and destruction are not opposites but entwined. They hint that the boundaries of the universe may not lie at the stars or the void beyond our telescopes, but deep within the mathematics of collapse, encoded in points of infinite curvature where reality itself is rewritten. This leads to a haunting thought. If singularities are indeed the seeds of universes, then countless realities may be unfolding inside black holes throughout the cosmos, each born from the collapse of a massive star, each expanding into a domain we can never perceive. Our universe could be one branch of an infinite cosmic tree, its roots entwined with the singularities of parent universes, its leaves reaching out into a horizon we can never cross. Every black hole in this scenario is both grave and womb, a paradox at the heart of existence. Yet, the singularity is also a place of awe, not just fear. It embodies extremes beyond imagination. Densities incomprehensible, curvatures infinite, energies immense. It is where our mathematical models fail, forcing humanity to confront the limits of knowledge. And it is precisely this mystery, this boundary of understanding, that draws curiosity and wonder. Singularities remind us that the universe is not merely a backdrop for life. It is an active, enigmatic participant, shaping reality in ways we can observe, measure, and only begin to imagine. As we contemplate singularities, we also confront the profound emotional contrast between human perception and cosmic reality. To the human mind, a singularity is terrifying, alien, destructive. To the universe itself, it is a tool of creation, a pivot around which space, time, and energy evolve. This duality, fear versus fascination, destruction versus creation, runs through the heart of the hypothesis that we may exist inside a black hole. Singularities are not merely endpoints. They are beginnings hidden in plain sight, the fulcrum of cosmic cycles that may stretch backward and forward beyond human comprehension. Finally, singularities force us to ask an existential question. If creation is born from collapse, then what role do we play as observers inside this expanding interior? Are we witnesses to a process that will one day fold inward again, carried along by the same gravitational currents that formed us? Or are we participants in a universe whose origins, structure, and fate are entwined with singularities far larger and more ancient than anything we can imagine? The singularity is both an end and a beginning, a mystery that challenges the boundaries of thought, physics, and human imagination, urging us to peer deeper, think bolder, and embrace the awe-inspiring paradox of existence. The universe we see around us is vast, breathtaking, and almost incomprehensible in scale. Stars scatter across the sky like diamonds on black velvet. Galaxies spiral with elegant grace, cosmic filaments stretch across billions of light years, and nebulae glow with ghostly hues of red, blue, and gold. Yet beneath this splendor lies a subtle, almost invisible scaffolding, the structure of spacetime itself. It is this hidden architecture that governs every movement, every collision, every formation of stars and galaxies. And if we are inside a black hole, as some theories suggest, then this architecture takes on an even deeper, more mysterious significance. Imagine the universe as a colossal, three-dimensional web. Dark matter forms the strands, invisible yet immensely powerful, stretching across space like the threads of a spider's web. Galaxies cling to these filaments, moving along their lengths, drawn by the gravity that flows through the web. Voids, immense empty regions, appear between the filaments, vast cosmic deserts where little matter exists. This cosmic web is not static. It evolves, shifts, and stretches, guided by the expansion of the universe, the pull of gravity, and perhaps the unseen currents of a black hole's interior. From our vantage point, the web seems infinite, but from a deeper perspective, it could be the interior geometry of a collapsing singularity, unfolding to reveal an interior cosmos far larger than we can imagine. Consider the motion of galaxies along this web. To an observer, they seem to drift, sometimes collide, sometimes spin in perfect isolation. But in truth, they are being carried along by the very fabric of space, flowing outward in a cosmic current. The expansion of the universe is not merely motion through emptiness, it is the stretching of the space in which everything exists. Distances grow not because galaxies are moving on their own, but because the medium of spacetime itself is expanding. In this sense, our universe is both the traveler and the terrain, moving through itself even as it unfolds from a possible black hole interior. The cosmic microwave background, the faint afterglow of the Big Bang, offers another piece of this puzzle. It is a whisper from the early universe, a snapshot of photons released nearly 380,000 years after the initial expansion. The remarkable uniformity of this radiation suggests a profound connection. The early universe must have been tightly knit, a compact, dense space where communication between regions was possible. If our universe emerged from the interior of a black hole, this early uniformity is precisely what we would expect. The interior collapse would have compressed matter and energy into a dense, nearly uniform state, primed for a dramatic expansion. The patterns we see today, the tiny variations in temperature, are fingerprints of that ancient compression, encoded into the very structure of reality. Now consider the role of dark energy. This mysterious force, which drives the accelerating expansion of the universe, may be intimately linked to the dynamics of a black hole interior. In a collapsing star, the interior spacetime stretches in unusual ways, creating pressure gradients and forces that resemble repulsive energy. If our universe resides inside such a structure, dark energy could be a manifestation of the underlying geometry, a reflection of the same physics that governs black hole interiors. It is a subtle, invisible hand, guiding the expansion of galaxies and cosmic structures with unyielding precision. The emotional contrast of this vision is striking. On one hand, we see beauty, stars, galaxies, filaments, and voids forming a cosmic tapestry beyond human comprehension. On the other hand, there is awe and fear, the realization that our universe, with all its splendor, may exist entirely within a gravitational trap. Everything we observe, everything we measure, is shaped by forces and boundaries we cannot perceive directly. The universe is both magnificent and confining, free in appearance yet bound by an invisible architecture. Imagine floating through this cosmic web. Galaxies drift past in silent grace. Light curves around massive clusters, creating arcs and distortions that play like reflections in a funhouse mirror. Nebulae bloom with color, waves of plasma and gas expanding in slow motion. You realize that every movement, every structure, is guided not by chance alone, but by the invisible geometry of spacetime itself. If our universe exists inside a black hole, then these patterns are echoes of the collapse that birthed it. The very order we see, the galaxies, the filaments, the voids, is a consequence of the hidden, curved interior. This realization also reframes our understanding of cosmic time. Time is not uniform across the universe. It flows differently depending on the curvature of spacetime and the intensity of gravity. In regions closer to massive structures, time slows relative to distant areas. If we inhabit a black hole interior, this variation is amplified on a cosmic scale. The universe we observe may be expanding at rates that differ depending on location, yet the overall flow creates the illusion of uniformity. It is a delicate interplay between geometry, motion, and perception, a cosmic choreography unfolding on scales beyond imagination. Finally, consider the philosophical weight of this vision. If the universe is a vast interior of a black hole, then we exist not in an open, infinite space but in a bounded, structured reality whose true boundaries are invisible. Every star, every galaxy, every photon we observe is part of an intricate architecture, a cosmic web flowing through a river of spacetime we cannot control. Our existence, our history, our perception of time, all unfold within this hidden structure. Yet within these constraints, life, consciousness, and awareness arise. The universe may be a vast, bounded interior, but it is also a cradle for complexity, beauty, and reflection. The paradox is profound. confinement and freedom, structure and creativity, collapse and expansion, all intertwined in the silent, elegant flow of spacetime. As we gaze into the night sky, it is easy to think of the universe as infinite, unbounded, and eternal. Stars twinkle in patterns we can trace, galaxies swirl in majestic spirals, and dark voids stretch beyond imagination. Yet, if our universe exists inside a black hole, then the vastness we perceive may be both true and deceptive. The cosmos could appear infinite from our vantage point, yet it is confined within a structure far beyond our comprehension, a singularity wrapped in the warped geometry of a parent universe. Every star, every galaxy, every photon may be contained within a boundary we cannot see, drifting along paths determined by the curvature of spacetime itself. Imagine approaching the edge of the observable universe. Light from distant galaxies reaches us after billions of years, stretched and dimmed by the expansion of space. Beyond this horizon lies an unknown realm, potentially vast, potentially infinite, yet forever inaccessible. If we are inside a black hole, this horizon is analogous to the event horizon of the black hole itself. It is not an edge in a conventional sense, but a limit imposed by geometry, a boundary beyond which light and information cannot travel. What exists beyond it may never be seen or measured, yet it may contain the origins of our universe, the remnants of a parent cosmos, or even the seeds of other universes waiting to unfold. The interior of a black hole, despite its terrifying density and curvature, may host an entire expanding universe. Galaxies drift apart, stars ignite, planets coalesce, and cosmic structures form, all within the curved fabric of spacetime. The singularity at the center is no longer just a point of destruction. It is the anchor of a cosmos, the hidden architect of every motion and formation. From inside, distances can stretch infinitely, yet from the outside, the black hole remains compact and incomprehensibly dense. This duality between inner freedom and outer confinement creates a profound sense of wonder and unease. Consider the motion of light within this interior. Photons travel along curves dictated by the geometry of spacetime. Paths that seem straight to us may, in reality, be bending along the invisible folds of the black hole's interior. Light from one corner of this universe may take circuitous routes, circling massive objects or threading along curved space, creating patterns of illumination that are subtle, complex, and astonishingly beautiful. The universe itself becomes a stage where light, matter, and time interact in a choreography guided not by chance, but by the hidden architecture of a collapsed star. This perspective also transforms our understanding of cosmic expansion. Galaxies are not moving through pre-existing space. Space itself is stretching. Distances grow not because objects travel, but because the medium they exist in expands. This expansion, driven by the hidden currents of spacetime, mirrors what happens within the interior of a black hole. The universe swells outward, its boundaries invisible, its architecture determined by the singularity at the center. Even the acceleration of cosmic expansion, driven by dark energy, may be understood as a consequence of the geometry of a black hole interior, a feature of the very spacetime we inhabit. The emotional contrast of this realization is striking. On one hand, the universe is breathtaking, vivid, vast, and filled with structure, light, and motion. On the other hand, it is terrifying to imagine that all this splendor may be bounded, confined, and ultimately determined by a structure whose rules we cannot directly observe. We are both free and trapped, observers and participants, moving along currents of spacetime we cannot alter. The beauty of the cosmos is inseparable from its hidden architecture, a reminder of the fragile interplay between perception and reality. Now, consider the philosophical implications. If the universe is contained within a black hole, then the question of origins shifts. The Big Bang may not have been a singular creation ex nihilo but the unfolding of a pre-existing structure, a bounce from a collapsed parent universe. Our cosmic history, our understanding of time, and even the laws of physics we observe could be shaped by conditions within this parent black hole. In this scenario, existence is recursive. Universes beget universes, each expanding within the heart of another, forming a chain of creation and collapse that may stretch infinitely backward and forward. The imagery is cinematic in scope. Picture the universe as a vast, flowing interior, galaxies drifting along invisible currents of spacetime, light bending in elegant arcs, nebulae glowing with ethereal colors. Imagine vast cosmic voids punctuated by clusters of stars, all contained within a structure whose true scale is unimaginable. From outside, it is a singularity, a pinpoint of infinite density. From inside, it is a living, expanding universe, teeming with motion, formation, and potential. This paradox, small yet immense, confined yet infinite, captures the mind and stirs both awe and fear. Finally, contemplate the idea that within this interior, new black holes form. Massive stars collapse, creating singularities that may themselves serve as seeds for other universes. Within the parent black hole, a branching tree of cosmic creation emerges. Each singularity is both an end and a beginning, a point of destruction that carries the potential for expansion, a paradox that reflects the deepest mysteries of existence. Our universe, in this vision, is one branch in an endless tree, connected to a parent cosmos we cannot observe, yet shaped by its collapse. In this scenario, the cosmos is not a single, isolated event but an ongoing narrative, a continuum of collapse and expansion, destruction and creation, contraction and rebirth. Every galaxy, star, and planet is part of this story. Every photon traveling across space is guided by the hidden geometry of a structure that may extend infinitely beyond our perception. And within this flowing interior, life, consciousness, and awareness arise, capable of observing and reflecting upon the vastness they inhabit, yet always constrained by the boundaries of the unseen architecture that defines their existence. The universe as an interior of a black hole transforms our understanding of reality. It forces us to see beauty and confinement, freedom and limitation, light and darkness as intertwined. It challenges our assumptions, expands our imagination, and presents a paradox that is as emotional as it is scientific. And in the silent, unseen currents of spacetime, the universe continues to expand, grow, and evolve, carrying everything within it toward destinies written by the hidden structure of reality itself. As we delve deeper into the possibility that our universe exists inside a black hole, we encounter the question of perception itself. How observers inside such a universe experience reality. To us, the universe appears vast, infinite even, with galaxies receding, stars igniting, and time flowing steadily forward. But if we are contained within the interior of a black hole, then everything we perceive is influenced by the curvature of spacetime and the geometry imposed by the singularity at the core. Our observations of distance, motion, and time are not purely objective. They are shaped by a structure far beyond our ability to directly sense. Imagine floating in a spaceship, traveling toward the outer regions of this interior universe. Stars drift past, their light bending in subtle arcs. Galaxies swirl, maintaining forms that seem elegant and familiar. Yet, every path you take is dictated by the underlying flow of spacetime. Even if your engines propel you at incredible speeds, the distances you traverse are expanding beneath your feet, carried along by the currents of a space that itself stretches and flows. Motion is an illusion, yet it feels real. The river of spacetime guides everything, creating the experience of travel, even as the true geometry remains hidden. This concept reframes the familiar laws of physics. Newtonian mechanics works because the curvature of spacetime is subtle on human scales, so we can ignore it in everyday life. But on cosmic scales, the flow and curvature dominate. Gravity is not merely a force. It is the warping of the river in which all matter is immersed. Time is not universal. It bends and stretches depending on proximity to dense objects and the overall curvature of spacetime. Light does not travel in straight lines but follows paths dictated by the interior geometry. To live inside a black hole interior is to exist in a world where intuition fails, yet the mathematics of relativity and geometry ensures consistency, allowing life and structure to emerge despite the underlying complexity. Now, imagine observing the expansion of distant galaxies. They appear to recede faster the further away they are, a phenomenon we measure as Hubble's law. In our model, this observation aligns naturally with the idea of an expanding black hole interior. The stretching of spacetime creates apparent motion that mirrors the expansion of our universe. Galaxies are not fleeing each other. They are anchored within the geometry of space itself, carried outward as the interior unfolds. The illusion of motion, generated by the underlying curvature, becomes indistinguishable from actual displacement. In this sense, cosmic expansion may be less about objects moving through space and more about the expansion of space itself, a perspective that reframes every observation we make of the cosmos. This framework also offers insight into the seemingly inexplicable phenomena of cosmic acceleration. Dark energy, mysterious and pervasive, drives the accelerating separation of galaxies. If our universe resides inside a black hole, dark energy may not be a separate entity but a manifestation of the curvature and dynamics of the interior. The geometry of spacetime could naturally induce the observed acceleration, without requiring exotic forces beyond the fabric of the black hole itself. The universe's expansion, then, is a reflection of the interior landscape, a phenomenon that is inevitable given the structure we inhabit. Consider the emotional resonance of this revelation. We are not drifting through a neutral, infinite void. We are carried along by a river of spacetime that is both beautiful and inescapable. Galaxies swirl in patterns dictated by hidden geometry. Light bends in arcs that encode the structure of the universe. Time flows differently in different regions, yet from our perspective, it seems uniform. The universe is at once magnificent and confining, a cosmic stage in which every motion, every interaction, every event is guided by invisible currents. Awe and unease coexist in equal measure. The interior of a black hole also changes how we perceive singularities. Traditionally, they are points of infinite density, endings of matter, and boundaries of spacetime. Inside the black hole, however, the singularity becomes a center, a focal point from which space unfolds. It is the origin of the interior, giving rise to regions of expanding spacetime in which galaxies form, stars ignite, and planets coalesce. The singularity is no longer simply destructive. It is creative, a hidden engine driving the evolution of a cosmos. It is simultaneously the center of collapse and the origin of expansion, a paradox that challenges human intuition while remaining mathematically consistent. Now envision the cosmic horizon, the boundary beyond which we cannot see. Just as an event horizon defines the outer limit of a black hole, the observable universe imposes a horizon determined by the finite speed of light and the curvature of spacetime. Beyond it, events unfold that we cannot detect, regions that remain forever hidden from view. In the black hole interior model, this horizon is natural. It is the manifestation of the interior geometry and the limits it imposes on perception. The universe is simultaneously vast and bounded, infinite in the interior sense yet restricted by the curvature that contains it. Finally, consider life, consciousness, and observation within this interior. All phenomena we observe, the birth of stars, the evolution of galaxies, the emergence of planets capable of supporting life, take place under the guidance of this hidden geometry. Our understanding of physics, from quantum mechanics to general relativity, emerges as a map of the currents and flows that shape reality. Life, in this context, is not a deviation from cosmic order but a natural consequence of the structure in which it exists. Consciousness itself becomes an observer of a universe flowing along invisible streams, aware of motion and expansion, yet unable to perceive the larger structure that guides it. In this vision, the universe is both beautiful and mysterious, governed by the subtle yet inexorable dynamics of spacetime. Every star, every planet, every galaxy is part of a flowing interior, carried along by curvature, expansion, and the hidden geometry of a singularity at the core. To inhabit such a universe is to experience freedom within boundaries, motion within structure, and creation within the paradox of collapse. Our universe, in this sense, is a cosmic river, both vast and contained, flowing along a path defined by forces we can observe but not fully comprehend. The question of scale in a universe that may exist inside a black hole is one of the most difficult for the human mind to grasp. On one hand, the cosmos appears unimaginably vast. Galaxies stretch across millions of light years, clusters form in intricate patterns, and cosmic filaments span distances beyond comprehension. On the other hand, if all of this exists within the interior of a black hole, then the entirety of the universe is, in a sense, bounded. Its true scale is determined not by the vast emptiness we perceive but by the curvature of spacetime that contains it. The paradox is profound. The universe feels infinite, yet it may be confined, its enormity a consequence of interior geometry rather than sheer freedom of space. Imagine standing at the edge of a galaxy, looking out toward the void between clusters. The distances are immense, seemingly endless, yet all of these stars, gas clouds, and dark matter filaments are carried along paths dictated by the underlying curvature of spacetime. The expansion we observe, the recession of galaxies, and the acceleration driven by dark energy are all consequences of the structure of the interior. Motion is not simply objects moving through space, it is space itself expanding, stretching, and flowing in a manner determined by the singularity at the center of the black hole. The boundaries of our universe are hidden, yet they exist, shaping every motion and every interaction. Consider light traveling across these vast distances. Photons emitted from the farthest reaches of the universe follow curved paths, their trajectories influenced by the geometry of the interior. A beam of light might spiral around massive clusters, bend near dark matter filaments, or take detours through regions of warped space, only to arrive at an observer billions of years later. These paths encode information about the underlying curvature, the hidden architecture of the black hole interior. Every photon becomes a messenger from the interior geometry, revealing patterns and dynamics that are otherwise invisible. The interior black hole hypothesis also reframes our understanding of cosmic structure formation. Galaxies are not merely random clusters of stars, they are organized by the invisible currents of spacetime. Filaments of dark matter provide the scaffolding along which baryonic matter collects, forming stars and galaxies in intricate arrangements. Voids appear between these filaments, vast empty spaces that highlight the structured nature of the cosmos. If we inhabit a black hole interior, this structure is a direct reflection of the curvature and dynamics of the singularity at the core, a blueprint encoded into spacetime itself. Now, consider the perception of infinity. From within, distances feel limitless. Light from the farthest galaxies takes billions of years to reach us, yet the interior may be bounded by the black hole's geometry. The illusion of unbounded space is created by the curvature of spacetime. The further we look, the more stretched and warped distances appear, creating the perception of an infinite cosmos. Yet, mathematically, the interior is finite, a closed, curved region of spacetime expanding outward from the singularity. The infinite appearance is a product of geometry, a trick played by the structure itself. Time, too, behaves in ways that challenge intuition. In regions of strong curvature, such as near the singularity or massive clusters, time slows relative to distant regions. From our perspective, the universe evolves in a steady flow, yet the interior dynamics may include time dilation effects that vary across the cosmos. These variations shape the evolution of galaxies, stars, and planetary systems. The history of the universe is not uniform, it is modulated by the interior geometry, with each region experiencing a slightly different rhythm. Observers inside perceive continuity, yet the underlying flow is far more complex than linear time suggests. The philosophical and emotional implications are staggering. We tend to think of the universe as either infinite or boundless, a backdrop for our existence. Yet if we are inside a black hole, the cosmos is both. It is a finite interior, bound by the geometry of the singularity, yet it feels infinite because of the way space and time are stretched and curved. The vastness we observe, the elegance of galaxy clusters, the beauty of nebulae, all of it is a product of this hidden architecture. We live within a structure that is both confining and free, finite and infinite, simple and extraordinarily complex. Visualize the cinematic imagery of this interior. Galaxies drift gracefully along the invisible currents of spacetime, clusters form in intricate patterns, and cosmic filaments stretch like threads in a vast, three-dimensional tapestry. Nebulae glow with vibrant colors, stars ignite and die in spectacular displays, and light bends around massive structures in arcs of ghostly elegance. The voids between filaments offer contrast, emphasizing the beauty of the organized chaos within. Every motion, every pattern, every structure is guided by the hidden curvature at the heart of the black hole. The universe becomes not just a place of observation but a living, flowing interior, a dynamic entity in which beauty, scale, and structure are intertwined. Finally, consider the recursive implications. Inside this black hole interior, new black holes form as massive stars collapse. Each of these may host their own interior universes, forming nested structures of incredible complexity. The cosmos is not a singular entity but a branching network of creation, where singularities give rise to interiors, and interiors give rise to expansion, structure, and motion. Our universe, in this vision, is a single branch in an immense, hidden hierarchy, connected to a parent cosmos, yet expanding outward with a beauty and scale that feels infinite to those inside. In this scenario, scale is not merely a measure of distance or size. It is a reflection of geometry, curvature, and flow. The universe is vast, elegant, and complex, yet fundamentally bound by the hidden interior of a black hole. Every galaxy, every star, every photon is carried along paths dictated by this architecture. Time flows, matter moves, and light travels according to the rules of curvature. Yet to us, it all appears natural, infinite, and comprehensible. This is the paradox of scale: finite yet infinite, confined yet boundless, structured yet fluid, a cosmic dance orchestrated by the unseen hand of spacetime itself. One of the most profound implications of living inside a black hole interior is the altered perception of causality. We are accustomed to cause and effect unfolding in predictable sequences. One event leads to another, time moves forward uniformly, and the universe behaves in a coherent, linear manner. But inside a black hole, where spacetime is curved to extremes, causality can behave in ways that defy our intuition. Events that seem sequential from one perspective may appear simultaneous from another. Light curves, distances stretch, and time flows at different rates depending on location. The familiar rhythm of cause and effect becomes malleable, shaped by the hidden architecture of the singularity at the center of the interior. Imagine a cosmic event unfolding. A massive star collapses, creating a black hole within the interior of our own black hole universe. From our vantage point, we may perceive the collapse as occurring gradually, its light dimming over time, matter spiraling inward. Yet, closer to the forming singularity, time behaves differently. Seconds stretch, years compress, and the sequence of events unfolds along curved trajectories dictated by spacetime itself. The collapse is both immediate and prolonged, simple and complex, terrifying and awe-inspiring. This duality illustrates the paradox of causality in extreme geometries. The universe is consistent, yet perception depends on the observer's position within the flow. The bending of light and matter also challenges our understanding of observation. Photons emitted from distant galaxies or collapsing stars travel along curved paths, weaving through regions of warped spacetime. The light that reaches us carries information about events that occurred billions of years ago, yet it is filtered through the curvature of space, stretched, delayed, or even redirected. The universe becomes a tapestry of intertwined timelines, a mosaic in which the past, present, and even aspects of the future can be encoded in the structure of the interior. Observation is no longer a simple act. It is an interaction with a dynamic, curved reality that continuously shapes what can be seen and measured. Now, consider the emergence of complexity within this interior. Galaxies form from swirling clouds of gas and dust, stars ignite and die, planets coalesce, and life emerges in small corners of the cosmos. Each process unfolds under the guidance of the hidden geometry. Motion, energy distribution, and gravitational interactions are all dictated by the curvature of spacetime. The interior of the black hole acts as both stage and director, shaping the evolution of matter while allowing patterns of remarkable complexity to develop. Life, consciousness, and even intelligence arise as natural consequences of this structure, perfectly tuned to the hidden rhythms of a flowing universe. The emotional contrast of this realization is profound. On one hand, the universe is majestic and orderly, with structures forming and evolving in harmony with the underlying curvature. On the other hand, it is humbling and terrifying. Every motion, every event, and every moment is bound by a geometry we cannot perceive, controlled by forces beyond our reach. We are both participants and spectators, capable of observing beauty and order yet powerless to alter the hidden currents that shape it. This duality inspires awe, a mix of wonder and existential unease, as we confront the limits of perception while marveling at the intricate cosmic dance around us. The recursive nature of creation inside a black hole interior adds further depth. As massive stars collapse to form new black holes, they may generate their own interior regions, potentially giving rise to nested universes. Each new interior expands along paths determined by its own singularity, creating a hierarchy of cosmic domains, each bounded yet expansive, finite yet seemingly infinite from within. Our universe may be just one level in an immense tree of creation, a branch emerging from a parent interior and giving rise to countless offspring in ways we can only begin to imagine. The singularity at the center of the parent black hole is the seed from which all this expansion flows, connecting us to a lineage of cosmic birth that stretches beyond perception. Consider the cosmic microwave background as a window into this structure. The faint afterglow of the early universe carries subtle variations that encode the initial conditions of our interior universe. Temperature fluctuations, patterns of density, and the large-scale distribution of matter reflect the underlying geometry imposed by the singularity. These signals are not just remnants of the Big Bang, they are fingerprints of the interior's curvature, a record of the forces that shaped the universe from its earliest moments. Observing them is like reading the encoded blueprint of the black hole interior, revealing the invisible scaffolding upon which all cosmic structures are built. The cinematic imagery of this interior is staggering. Galaxies drift along invisible currents, stars ignite in brilliant bursts, and nebulae glow with ethereal colors. Light bends, creating arcs and loops that reveal the warping of space. Voids stretch between filaments of dark matter, emphasizing the patterns created by curvature and flow. Every structure, every pattern, every motion is a consequence of the hidden geometry, yet to an observer, it appears natural and seamless. The interior is at once a dynamic, living system and a meticulously orchestrated environment, a universe flowing in harmony with the unseen architecture of spacetime. Finally, the philosophical implications cannot be overstated. Living inside a black hole interior challenges every assumption about space, time, and existence. The universe is finite and bounded, yet appears infinite. Time flows differently depending on location, yet life and complexity can develop. Cause and effect are relative, yet patterns emerge. Motion is guided by curvature, yet we experience it as freedom. This duality, between perception and reality, freedom and confinement, complexity and underlying order, defines our experience within the interior. It suggests that existence itself is a delicate balance between the observable and the hidden, between the flow of events and the geometry that governs them, a cosmic paradox that inspires both awe and reflection. One of the most compelling aspects of the black hole interior hypothesis is how it reshapes our understanding of cosmic horizons. The observable universe, limited by the speed of light and the finite age of cosmic expansion, presents a boundary beyond which we cannot see. This horizon gives the illusion of a finite sphere in which all matter, energy, and light exist. Yet, if our universe resides inside a black hole, this horizon is not merely a limit of observation. It is a manifestation of the curvature of spacetime itself. The edge of the observable universe is a window into the unseen geometry, where the laws of physics bend, distances stretch, and the very flow of time alters. Beyond this horizon lies the true vastness of the interior, a realm of expansion and complexity that remains inaccessible, yet profoundly influences everything we can observe. Imagine standing at the edge of this cosmic horizon. Galaxies stretch toward the limit of perception, their light dimming and reddening as it travels across the expanding interior. The farther we look, the slower time appears to pass, and the farther we must peer to reconstruct events that occurred billions of years ago. Space seems infinite, yet it is curved, wrapped in layers of unseen geometry. The horizon is not a wall but a boundary of perception, a curtain beyond which the structure of the interior universe is concealed. Every photon we receive from this boundary carries information about the expansion, curvature, and dynamics of the interior, encoding clues about the hidden singularity at its heart. This horizon also reframes our understanding of the universe's age. Time is relative, and within the interior of a black hole, regions closer to massive concentrations of matter experience slower time. The photons arriving from the edge of the observable universe may have taken billions of years to reach us, yet the actual evolution of those regions could differ dramatically from our local frame. The horizon, then, is a dynamic boundary shaped not just by distance, but by the flow of spacetime and the relative passage of time. It is a living interface between the observable and the hidden, a cosmic liminal space where mystery and observation intersect. Consider the motion of galaxies at the edge of this horizon. They appear to recede faster with increasing distance, a phenomenon captured in Hubble's law. Yet this motion is not merely a flight through space, it is the stretching of space itself, amplified by the interior geometry of the black hole. The apparent acceleration we measure as dark energy may be a natural outcome of the curvature of spacetime, a consequence of existing within an expanding interior. Galaxies drift along paths dictated by the hidden structure, yet to observers like us, it appears as though they are racing away into an infinite void. The paradox is profound. The universe feels boundless, yet every motion is guided and constrained by the interior geometry of a singularity we cannot observe directly. The cosmic microwave background further illuminates this structure. Its faint glow, uniform yet subtly varied, is a relic of the early expansion of the interior. The temperature fluctuations and density variations carry encoded information about the curvature of the black hole interior, revealing how matter and energy were distributed in the initial moments of expansion. These fluctuations are the fingerprints of the singularity, the evidence of forces shaping the universe long before stars or galaxies formed. By observing this radiation, we are essentially reading the blueprint of the hidden architecture that governs the motion, structure, and evolution of everything within the interior. The cinematic imagery of the horizon is both beautiful and unsettling. Galaxies drift like lanterns along invisible currents, light bending and twisting through warped spacetime. Nebulae glow with ethereal colors, clouds of gas forming intricate patterns along the cosmic web. Voids stretch endlessly, punctuating the interior with darkness that emphasizes the contours of curvature. The boundary of perception is both a limit and a lens, shaping how we see the universe while concealing the enormity and complexity beyond. From our perspective, the universe is majestic, infinite, and harmonious. From a deeper perspective, it is part of a curved, bounded interior, flowing outward from a singularity that anchors everything we observe. Philosophically, this horizon challenges our notions of reality. We tend to think in terms of absolute beginnings and endings, finite or infinite space and uniform time. But inside a black hole, these assumptions break down. Boundaries are relative, time is fluid, and scale is determined by geometry rather than perception alone. The horizon represents the interface between what we can know and what remains forever hidden, a reminder of both the power and the limits of human understanding. It is a point of tension and contrast, the known versus the unknown, the observable versus the hidden, freedom versus confinement. Within this framework, every observation becomes a dialogue with the interior geometry. The light we see, the motion we measure, and the patterns we detect are not merely empirical facts. They are reflections of the underlying curvature of spacetime, encoded in the expansion of the interior and shaped by the singularity at its center. Our universe, in this sense, is not a static or passive space but an active, flowing interior, guided by the hidden structure of the black hole. Life, matter, energy, and even consciousness emerge within this dynamic architecture, all interacting with the curvature and flows that define the horizon. Finally, consider the emotional weight of this realization. The cosmic horizon is at once protective and confining, beautiful and terrifying. It frames our perception, shapes our understanding of scale, and encodes the hidden forces that govern motion, structure, and evolution. We exist within a universe that appears infinite, yet is bounded. We experience time and motion, yet these are relative to the curvature of spacetime. We perceive causality, yet it is malleable in the interior. The horizon, a boundary of perception, becomes both a limit and a lens, challenging our understanding while inviting awe. It is a threshold, a frontier of mystery, a place where observation meets the hidden reality of a universe flowing outward from the heart of a singularity, where every galaxy, star, and photon is part of a cosmic architecture far beyond human comprehension. As we delve deeper into the concept of our universe existing inside a black hole, we confront the most enigmatic and paradoxical element of all, the singularity itself. Traditionally, a singularity is thought of as a point of infinite density, where space and time collapse and the known laws of physics cease to function. It is the ultimate boundary of comprehension, a place where matter is crushed to inconceivable scales and conventional notions of time and causality break down. Yet, in the context of an interior universe, the singularity is no longer merely destructive. It may be the source from which all creation flows, the hidden engine behind the expansion, structure, and complexity of the cosmos we inhabit. Imagine the moment of singularity formation within a collapsing star. The star, once vast and luminous, shrinks under the inexorable pull of gravity. Its core compresses, electrons and protons forced into a dense, unfathomable state. Pressure, temperature, and density rise beyond comprehension, reaching extremes that seem impossible to measure or visualize. In these final moments, space itself folds, curving into a shape dictated by the mathematical framework of general relativity. Time begins to behave unpredictably, dilating and stretching relative to regions farther from the singularity. From the outside, the collapse seems gradual. From the interior perspective, the process may be instantaneous, a cosmic heartbeat compressed into a single, infinite point. Now, consider the nature of this singularity as the seed of a universe. While external observers perceive it as an endpoint, within the interior, it functions as a beginning. Space unfolds from the singularity, matter and energy organize, and the fabric of spacetime stretches to create distances, structures, and cosmic evolution. Galaxies, stars, and planets emerge from the initial compression, guided by the curvature imposed by the singularity. The singularity is both the anchor and the womb of the universe. It destroys locally yet creates globally, shaping everything within the interior according to the hidden logic of curvature, expansion, and gravitational dynamics. The mathematics of this process are astonishing. Einstein's equations describe how mass and energy dictate the curvature of spacetime, while the singularity embodies the extremes of these effects. In the interior, spacetime can expand in directions unobservable from the outside, creating an interior universe that appears vast and infinite from within yet is bounded by the black hole's geometry. Quantum mechanics adds another layer of complexity. The laws of quantum physics suggest that information cannot be destroyed, even within a singularity. This implies that the singularity encodes the blueprint of everything that will exist in the interior. The distribution of matter, the structure of galaxies, the formation of stars, and potentially even the conditions for life. In this way, the singularity is a cosmic memory, preserving and organizing the potentialities of a universe yet to unfold. Now, envision the cinematic image of this interior universe. Space stretches in all directions from the singularity, galaxies drifting along invisible currents shaped by the curvature of spacetime. Light bends and warps around massive structures, creating arcs and loops that trace the geometry of the interior. Nebulae glow in ethereal colors, clouds of gas and dust forming intricate patterns dictated by gravitational flows. The singularity is at the center of it all, unseen yet omnipresent, the hidden director orchestrating the cosmic dance. Time flows differently in various regions, yet the interior appears coherent, natural, and breathtakingly beautiful to any observer living within it. Philosophically, the singularity challenges our most basic assumptions about beginnings and endings. We are conditioned to think of creation as a process starting from emptiness and destruction as a process leading to oblivion. But in this scenario, creation arises from collapse. Destruction is the mechanism through which structure and complexity emerge. The singularity embodies the duality of existence. It is both finite and infinite, destructive and creative, terrifying and awe-inspiring. This duality is central to understanding the emotional weight of the hypothesis that our universe is an interior of a black hole. It forces us to confront the paradox that what seems like an end from one perspective may be the origin from another. The singularity also reframes our understanding of time itself. In classical physics, time is linear and universal, a steady flow in which events unfold sequentially. Within a black hole interior, however, time is a relative, malleable dimension shaped by the curvature of spacetime. Near the singularity, time can stretch or compress dramatically. Events that appear sequential from a distant perspective may occur simultaneously from the interior viewpoint. Cosmic evolution, the birth of stars, the formation of galaxies, the emergence of planets, is guided by this flexible time, producing a universe that feels continuous and coherent to those inside, yet is fundamentally shaped by the underlying singularity. Consider the emotional contrast this creates. On one hand, the singularity is terrifying, a point of infinite density and incomprehensible extremes. On the other hand, it is magnificent, a source of creation that gives rise to galaxies, stars, and the very conditions that allow life to emerge. It embodies the tension between fear and wonder, destruction and creation, the finite and the infinite. This contrast is central to the cinematic experience of contemplating our universe as an interior of a black hole. The extremes of scale, density, and energy are both threatening and awe-inspiring, evoking emotions that straddle the line between existential dread and cosmic fascination. Furthermore, the singularity may hold the key to understanding the origin of fundamental constants, the precise values that govern physics in our universe. If the interior universe unfolds from the singularity, then its laws, constants, and structures are encoded from the start. The speed of light, gravitational strength, and quantum behavior may all reflect the initial conditions imposed by the singularity. In this way, the singularity is not just a point of origin, but the hidden architect of all physical reality, determining the rules that govern existence, life, and cosmic evolution. The cinematic imagery continues to expand. Imagine the first moments of cosmic evolution emerging from the singularity. Dense clouds of matter swirl, light ignites in the earliest stars, and galaxies begin to take form. Time stretches differently in different regions, yet the patterns of motion, energy, and structure remain coherent. Every formation is a direct consequence of the initial conditions imposed by the singularity, every photon carries the signature of its curvature, and every orbit traces the invisible architecture of spacetime. The universe is alive with motion, guided by a hidden hand that is both destructive and creative, terrifying and magnificent. Finally, the singularity embodies a paradox that challenges human perception. It is both nothing and everything. To the outside observer, it appears as a point, a finality. Within, it is the source of vast interiors, galaxies, stars, planets, and possibly life itself. It is the origin of expansion, the center of curvature, and the anchor of all motion. It is a cosmic mystery that forces us to reconsider what we mean by creation, destruction, and the nature of existence itself. In embracing this paradox, we confront the awe-inspiring possibility that our universe is not separate from collapse but born from it, a living interior flowing outward from a singularity that remains forever hidden, yet is the heart of everything we observe. As we explore the implications of our universe existing inside a black hole, we are confronted with the concept of cosmic feedback, the intricate interplay between matter, energy, and spacetime that governs the evolution of the interior. In a traditional universe, stars form, live, and die, galaxies rotate and interact, and cosmic structures evolve over billions of years. Inside a black hole interior, however, these processes are not isolated. they are intimately connected to the underlying geometry imposed by the singularity at the center. Every event, from the birth of a star to the collision of galaxies, is both influenced by and a contributor to the flow of spacetime, creating a dynamic feedback loop that shapes the cosmos in ways that are both predictable and astonishingly complex. Imagine a massive star reaching the end of its life. Within a conventional framework, it collapses under gravity, potentially forming a neutron star or black hole. But within a black hole interior, this collapse has additional layers of significance. The star's mass and energy contribute directly to the curvature of spacetime, altering the paths of nearby matter and light. Its explosion, if it becomes a supernova, sends shockwaves of energy through the surrounding region, redistributing matter along the invisible currents of the interior. The feedback is not merely local, it ripples through the cosmic web, influencing the motion of galaxies, the formation of new stars, and even the acceleration of expansion. In this sense, the universe is not a passive arena but a responsive system, continuously adapting and evolving under the guidance of its hidden architecture. Now consider galactic collisions, some of the most spectacular and violent events in the cosmos. When two galaxies merge, stars are flung into new orbits, gas clouds compress to form new regions of star formation, and supermassive black holes at the centers may merge, releasing tremendous energy. Within the black hole interior model, these events also interact with the curvature of spacetime. The merger changes the local geometry, bending light in new ways, altering the flow of energy, and subtly modifying the structure of the surrounding cosmic web. Each collision becomes part of the ongoing feedback loop, a mechanism by which matter, energy, and spacetime co-evolve, guided by the hidden influence of the singularity. The concept of dark matter and dark energy also fits elegantly within this framework. Dark matter, the invisible scaffolding holding galaxies together, may be understood as a manifestation of the curvature of the black hole interior. Its influence guides the motion of stars and galaxies along the underlying structure, creating the cosmic web and stabilizing regions of matter. Dark energy, driving the accelerating expansion of the universe, may similarly be a reflection of the interior geometry, a force that emerges naturally from the dynamics of the singularity and the interior spacetime. Together, dark matter and dark energy represent the hidden hands of the interior, shaping feedback and structure on cosmic scales. The cinematic image of this feedback is awe-inspiring. Picture galaxies spiraling along invisible currents, their stars moving in elegant arcs. Supernovae ignite, casting brilliant waves of light across nebulae, while jets from supermassive black holes carve paths through interstellar clouds. The dark matter scaffolding bends the flow of matter, while spacetime itself stretches and expands, carrying galaxies outward in a majestic, almost choreographed motion. It is as if the universe is a living entity, breathing and responding to every event, every explosion, every gravitational tug, guided by the hidden architecture of a singularity that lies beyond perception. From a philosophical perspective, cosmic feedback within a black hole interior suggests a universe that is both self-organizing and deterministic. Events are shaped by underlying structure, yet the complexity of interactions allows for emergent phenomena, including the formation of stars, planets, and potentially life. Life itself, in this model, is not an anomaly but a natural consequence of a system that responds to energy, matter, and curvature in a coordinated and adaptive manner. The universe is not a random collection of events but a coherent, responsive entity, evolving according to the rules of the interior while allowing for complexity, diversity, and creativity to emerge. Time, as we experience it, is also affected by this feedback. Near massive structures or regions of high curvature, time slows, creating variations in how events unfold. Stars may form faster or slower, cosmic collisions may appear stretched, and the propagation of light may be delayed or bent in unusual ways. The passage of time is thus intertwined with the feedback mechanisms of the universe. Curvature shapes motion, motion affects energy distribution, energy influences structure, and structure, in turn, modifies curvature. This continuous loop creates a rhythm, a cosmic heartbeat, that governs the evolution of the interior on scales that span billions of years. Now, imagine the emotional impact of witnessing such a universe. The beauty of the cosmos is intertwined with its hidden forces. Galaxies drift in choreographed patterns, nebulae glow with ethereal colors, and light bends and twists in graceful arcs. Every motion, every explosion, every structural formation is part of a greater system, a dynamic feedback loop invisible to the naked eye yet omnipresent in shaping the universe. Awe and humility intertwine. We observe the elegance of cosmic evolution while realizing that the forces guiding it are beyond our direct perception, operating in silence through curvature, expansion, and the unseen influence of the singularity. The feedback mechanisms also offer insight into the origin of large-scale structures. The cosmic web, with its filaments and voids, emerges naturally as matter responds to gravitational flows guided by curvature. Clusters of galaxies form at intersections of filaments, while voids arise where matter is sparse. Supernovae, galactic mergers, and energetic jets contribute to redistribution and evolution. The feedback loop ensures that structure is neither random nor chaotic. It is patterned, evolving in a way that balances stability with dynamic motion, chaos with coherence. The universe, in this sense, is both predictable and endlessly surprising, a vast interplay of cause and effect mediated by the hidden architecture of a black hole interior. Finally, the singularity at the center of the interior acts as the ultimate regulator of this feedback. Its curvature defines the geometry in which all matter and energy move, ensuring that feedback occurs within coherent boundaries. While events may appear chaotic on local scales, they follow the broader patterns imposed by the interior structure. The singularity is both anchor and conductor, maintaining the balance between motion, energy, and spacetime, enabling the universe to evolve in a complex, ordered, and aesthetically breathtaking manner. The cosmic feedback loop is thus a fundamental feature of the interior universe, illustrating how matter, energy, and spacetime interact to create a living, dynamic cosmos that is both bound by geometry and free in its unfolding. As we continue to explore the concept of a universe existing inside a black hole, one of the most profound areas of inquiry is the relationship between consciousness and the cosmos. Consciousness, the ability to perceive, reflect, and experience, emerges within a universe whose structure is dictated by curvature, expansion, and the hidden geometry of a singularity. From the smallest particles to the vast web of galaxies, every event and interaction is shaped by spacetime, yet conscious observers arise, capable of comprehending portions of this immense interior. The very act of observation becomes a bridge between the unseen architecture of the universe and the emergent phenomena of life, intelligence, and awareness. Imagine an intelligent being, ourselves for instance, looking up at the night sky, observing the stars, galaxies, and cosmic structures. To us, the universe seems vast and infinite, governed by laws we can begin to understand. Yet, from the perspective of the black hole interior model, every observation we make is a dialogue with the hidden structure. The patterns we perceive, the rotation of galaxies, the expansion of space, the paths of light across billions of years, are shaped by curvature that we cannot directly detect. Consciousness, then, becomes an interface between perception and the underlying reality, a mechanism through which the universe begins to reflect upon itself. The concept of time becomes particularly intriguing in this context. Conscious observers perceive time as linear, a continuous progression from past to present to future. Yet within a black hole interior, time is malleable, stretching and compressing depending on location and the density of matter. Near massive structures, time flows differently than in the emptier reaches of the cosmos. For a conscious being, this means that perception, memory, and anticipation are relative, subtly influenced by the geometry of the universe. Moments can feel fleeting or eternal, and the experience of causality is shaped by the curvature in which it unfolds. Consciousness becomes a lens through which the complex rhythms of spacetime are experienced, even if only partially understood. Consider the emergence of life on a planetary surface. From the black hole interior perspective, the formation of a planet capable of supporting life is not a random occurrence but a natural outcome of the curvature, distribution of matter, and energy flows within the interior. Chemical reactions, energy gradients, and environmental conditions unfold under these hidden constraints, yet they lead to the astonishingly complex phenomenon of self-replicating systems. Life is both a product of local conditions and a reflection of global geometry, an emergent property arising from the interplay of structure, energy, and spacetime. Consciousness, in turn, is an extension of this complexity, a phenomenon capable of observing and interpreting the universe that gave rise to it. The cinematic imagery of conscious experience within such a universe is breathtaking. Imagine standing on a planet's surface at night. Stars trace arcs across the sky, light bent and stretched by curvature. Distant galaxies glow with colors shifted by expansion. Nebulae shimmer with intricate patterns shaped by cosmic flows. The observer perceives a universe that is beautiful, dynamic, and harmonious, yet the underlying forces shaping these phenomena remain hidden, invisible to the senses. Consciousness interprets and creates meaning from these patterns, transforming raw phenomena into awe, wonder, and curiosity. In this sense, the mind is a storyteller, translating the complex interplay of spacetime, energy, and matter into narratives that guide understanding and imagination. The interplay between observation and reality also has profound philosophical implications. If the universe is shaped by the hidden geometry of a black hole, then our perception of physical laws is not merely a reflection of objective truth but a translation of these deeper structures into comprehensible patterns. Gravity, motion, energy, and time are experienced as coherent, predictable phenomena because the interior is structured in a way that allows complexity and consciousness to emerge. In this sense, the universe is self-consistent and life-permitting, a vast system whose hidden architecture enables observers to exist and reflect upon it. The act of observation becomes not just a passive reception of data but an active engagement with the cosmic structure. Consider the emotional resonance of this idea. Consciousness, though small and fragile in scale, is intimately connected to the grand dynamics of the interior universe. Every observation, thought, and reflection is part of a larger dialogue with the hidden forces that govern cosmic evolution. Stars ignite and die, galaxies collide, and light bends along curved paths, all while conscious beings ponder their place in the cosmos. Awe and humility intertwine, as the observer realizes that the very ability to perceive is enabled by the geometry, expansion, and feedback mechanisms of the interior. The vast and the intimate coexist in this space, producing a unique blend of existential wonder and philosophical reflection. Time dilation near massive structures also affects consciousness in unexpected ways. Observers in regions of strong curvature may experience time differently from those in flatter regions. A day for one observer might correspond to years elsewhere, altering the perception of change, evolution, and cosmic history. This creates a universe in which experience is relative, yet patterns of cause, effect, and emergence remain consistent within local frames. Consciousness thus interprets reality in ways that are inherently linked to spacetime geometry, producing perceptions and insights that are localized yet connected to the broader interior dynamics. Now imagine the recursive impact of consciousness on cosmic understanding. As intelligent life observes, measures, and models the universe, it deciphers patterns that hint at the underlying curvature and structure of the interior. Mathematics, physics, and philosophy emerge as tools to translate hidden dynamics into comprehensible frameworks. Consciousness becomes both observer and interpreter, capable of glimpsing the architecture of the universe while remaining bound by the limits of perception. In this way, awareness itself becomes a bridge between the immeasurable scale of the interior and the intimate scale of sentient experience. The cinematic interplay of consciousness and cosmic structure extends even to the sense of identity. We are small, fragile observers in a vast, curved universe, yet we are capable of understanding, imagining, and reflecting. Our very thoughts trace arcs through space and time, engaging with patterns set in motion billions of years ago. We perceive galaxies as coherent entities, stars as stable beacons, and cosmic history as flowing narratives, even as the hidden forces guiding these phenomena remain beyond direct perception. The interior universe and consciousness are entwined, each shaping the other, producing a dynamic, reflective, and deeply aesthetic experience of existence. Finally, the emotional contrast inherent in this realization is profound. Consciousness is fragile yet powerful, limited in scope yet capable of abstract understanding, temporary yet connected to processes spanning billions of years. The universe appears both infinite and bound, structured and dynamic, awe-inspiring and humbling. Observers are part of a cosmic feedback loop, where hidden architecture shapes perception and perception interprets hidden architecture. In this interplay, consciousness is both participant and witness, capable of experiencing the beauty, terror, and wonder of an interior universe flowing outward from a singularity, a universe whose hidden geometry defines not only space and time but the very conditions of awareness itself. As we move deeper into the exploration of our universe as the interior of a black hole, the concept of cosmic evolution takes on an unprecedented dimension. In a conventional understanding, the evolution of the universe is a linear progression. The Big Bang, the formation of matter, galaxies, stars, planets, and eventually life. However, within a black hole interior, evolution is intricately tied to the geometry of spacetime, the flow of matter and energy, and the hidden influence of the central singularity. Every event, from the collapse of a massive star to the expansion of cosmic filaments, is shaped by curvature and feedback mechanisms, producing a universe that evolves in harmony with its underlying structure while giving rise to complexity and emergent phenomena. Imagine a galaxy forming billions of years ago within the interior. Clouds of gas and dust swirl along invisible currents, collapsing under gravity while guided by the curvature imposed by the singularity. Stars ignite, planets coalesce, and nascent systems take shape in patterns dictated by spacetime geometry. Supernovae erupt, scattering heavier elements into the surrounding medium, seeding future generations of stars and planets. These processes are not isolated. They form a network of interdependent events where every explosion, merger, and collapse subtly reshapes the interior environment. Cosmic evolution is therefore not random but highly orchestrated, a symphony of energy, matter, and curvature playing out over billions of years. Time itself plays a fluid and fascinating role in this evolution. Within the black hole interior, time is relative. Regions near massive structures experience dilation, while emptier regions flow more freely. This creates a tapestry of temporal experience where events may unfold at dramatically different rates across space. One galaxy may evolve over billions of years in what seems like a steady, linear progression, while in another region near high curvature, the same processes could appear compressed or extended. The evolution of the universe is therefore a multidimensional phenomenon, with consciousness embedded within it perceiving a linear narrative while existing within a complex, curved temporal framework. The role of feedback mechanisms in cosmic evolution cannot be overstated. Supermassive black holes at the centers of galaxies regulate star formation through powerful jets and winds, while stellar deaths enrich the interstellar medium with heavy elements. These interactions create cycles that both stabilize and transform galaxies over time. Within the black hole interior, this feedback is amplified by the curvature of spacetime. Energy and matter flow along paths shaped by geometry, reinforcing patterns of structure while allowing for emergent phenomena. Evolution is thus a dynamic interplay between local events and global architecture, producing a cosmos that is coherent, yet endlessly surprising. Visualize the cinematic unfolding of this evolution. Nebulae glow with incandescent hues, sculpted by stellar winds and radiation pressure, while stars ignite and fade, tracing arcs across the sky. Galaxies rotate gracefully, their spiral arms filled with newborn stars, dust and gas, moving along currents defined by curvature. Collisions between galaxies create bursts of star formation, sending shockwaves of energy that ripple through space. Light bends and stretches across these interactions, painting arcs and patterns in the cosmos. Every formation, every motion, every interaction is a testament to the hidden architecture of the interior, a cosmic choreography orchestrated by forces we cannot directly perceive. The philosophical implications of this perspective are profound. Evolution is no longer merely the unfolding of matter and time but a process embedded within the geometry of the universe itself. Structure, complexity, and life emerge not as anomalies but as natural outcomes of a system governed by curvature, feedback, and expansion. Consciousness arises as part of this evolutionary tapestry, capable of perceiving patterns, generating knowledge, and reflecting upon its own origins. The universe is simultaneously a stage for evolution and a participant in it, its architecture shaping processes while being shaped by their outcomes. Dark matter and dark energy play pivotal roles in this evolutionary process. Dark matter guides the motion of galaxies, stabilizes structures, and forms the scaffolding along which cosmic filaments develop. Dark energy drives accelerated expansion, shaping the distances between clusters and influencing the dynamics of large-scale structures. Within a black hole interior, these forces are not abstract or mysterious but direct consequences of curvature and spacetime dynamics. They facilitate evolution, ensuring that galaxies, stars, and planets form in patterns conducive to complexity and stability, while also enabling diversity, motion, and the emergence of life-supporting environments. Consider the emotional contrast inherent in cosmic evolution within a black hole interior. On one hand, evolution is majestic, orderly, and awe-inspiring, revealing the intricate beauty of the universe. Galaxies swirl, stars ignite, and light bends in arcs of cosmic elegance. On the other hand, evolution is violent, unpredictable, and humbling. Supernovae explode, black holes consume matter, and galaxies collide with cataclysmic force. This interplay between creation and destruction, stability and chaos, beauty and terror, defines the experience of contemplating a universe governed by hidden geometry. It evokes wonder, fear, and reverence simultaneously, illustrating the complex duality at the heart of existence. Cosmic evolution also shapes the conditions for life. Planetary systems emerge within stellar nurseries, receiving the necessary chemical elements from previous generations of stars. Time, curvature, and energy flow converge to produce stable environments where chemical reactions can proceed, eventually giving rise to self-replicating molecules and complex organisms. Within the black hole interior framework, these processes are not coincidental but emergent outcomes of the hidden architecture, where feedback, geometry, and temporal variations create niches conducive to life. Conscious observers, in turn, arise as natural participants in this grand evolutionary scheme, capable of perceiving, understanding, and reflecting upon the universe that produced them. Imagine the cinematic imagery of life and evolution embedded within cosmic patterns. A planet orbits a star whose light has traveled along curved paths, illuminating continents, oceans, and skies. Geological processes, climate systems, and chemical cycles unfold in harmony with energy flows dictated by curvature. Life emerges, evolves, and adapts, interacting with the environment in ways that mirror the feedback mechanisms operating on cosmic scales. Conscious beings arise, capable of gazing at the night sky, observing galaxies shaped by curvature, and reflecting on the origins of existence. Evolution in this context becomes a multi-scale phenomenon, planetary, biological, and cosmic processes interwoven in a single tapestry governed by hidden geometry. Finally, cosmic evolution within a black hole interior exemplifies the unity of scale. From the subatomic interactions driving stellar fusion to the gravitational flows shaping galaxies, all processes are interconnected, reflecting the influence of the singularity at the center. The universe is not a collection of isolated events but an integrated system, evolving according to rules embedded in the hidden structure of spacetime. Life, consciousness, and intelligence emerge naturally from this framework, providing observers with the opportunity to perceive, interpret, and reflect upon the processes shaping their existence. The evolution of the universe becomes not merely a scientific concept but a profoundly cinematic and philosophical journey, revealing the harmony, complexity, and wonder of a cosmos flowing outward from the heart of a singularity. The flow of information within a black hole interior universe is a phenomenon that reshapes our understanding of reality itself. Every particle, photon, and event carries information encoded in the curvature of spacetime, linking past, present, and future. Photons traveling from distant stars trace bent paths, their properties subtly altered by the geometry they traverse. Observers reading this light are interpreting fragments of the interior's hidden architecture, decoding signals embedded in cosmic flows. Quantum entanglement further complicates and enriches this picture, connecting regions that appear distant yet are linked through curvature, preserving coherence across the interior. Information is never lost, it is transformed. Supernovae scatter elements that seed planets and life, black holes redistribute energy, and galactic collisions encode new patterns into the evolving cosmos. These processes form a dynamic, self-maintaining archive, ensuring that complexity, structure, and consciousness can emerge. Time, relative and nonlinear within the interior, further shapes the flow of information. Events unfold at varying rates depending on curvature, creating a multidimensional narrative where cause and effect are interconnected yet locally coherent. The philosophical and emotional impact is profound. Information flow ensures order in a universe that might otherwise appear chaotic, while also maintaining mystery, as the full scope of the interior's memory remains inaccessible. Conscious observers perceive fragments, infer patterns, and reflect upon the hidden structure, bridging perception and reality. The universe becomes a living record, and consciousness a medium through which the interior understands itself. Every observation, calculation, and reflection taps into this flow, connecting intelligence to the singularity's architecture. The cosmos is at once intelligible and unfathomable, its memory encoded in light, matter, and energy, preserving coherence, enabling evolution, and sustaining the possibility of awareness within its vast, curved interior. Within a black hole interior universe, the laws of physics are expressions of hidden geometry rather than arbitrary rules. Gravity, quantum mechanics, and electromagnetism emerge from the curvature of spacetime dictated by the singularity. Each particle's motion, each interaction of energy, is shaped by this underlying structure, producing a cosmos that is simultaneously coherent and dynamic. Observers perceive local laws, yet these are reflections of a broader, unified architecture. Particles travel along curved trajectories, photons bend under gravitational influence, and quantum phenomena unfold in patterns constrained by geometry. Constants like the speed of light or Planck's constant are set by boundary conditions of the interior, enabling matter, stars, galaxies, and eventually life to emerge. Time is nonlinear, stretching and compressing according to local curvature, influencing the apparent rate of processes and the perception of causality. The universe is both orderly and adaptive, with feedback loops ensuring stability while allowing complex evolution. Cinematic imagery illustrates this elegance. Galaxies rotating with graceful arcs, nebulae illuminated by star formation, supernovae scattering elements across curved paths, and black holes regulating cosmic structure. Conscious observers, capable of reflection and measurement, tap into these principles, interpreting patterns and understanding laws. Physics becomes not merely a predictive tool but a bridge connecting perception to the hidden singularity. The interior universe is self-consistent and awe-inspiring, its laws a manifestation of geometry, curvature, and energy flow. Observers are participants in a cosmos that is both intelligible and mysterious, bound by rules encoded in spacetime, yet expansive, dynamic, and infinitely intricate. Considering the possibility that humans exist inside a cosmic black hole leads to both scientific and existential reflection. If the universe is an interior of a singularity, every star, planet, galaxy, and life form is part of a system shaped by hidden geometry. The singularity dictates curvature, energy flows, and the evolution of structure, ensuring coherence while allowing dynamic, emergent complexity. Conscious beings arise naturally, capable of perceiving and reflecting upon the patterns around them. Galaxies drift along curved paths, stars ignite and fade, and black holes redistribute matter, energy, and information. Time is relative, stretching and contracting depending on location, affecting both evolution and perception. Feedback mechanisms, from star formation to galactic interactions, maintain stability while enabling change. Life and consciousness emerge as natural consequences, reflections of a universe organized to produce complexity, stability, and awareness. Observers interpret patterns, study laws, and participate in the unfolding cosmic story, bridging perception with hidden architecture. Emotionally, this perspective is both humbling and awe-inspiring. The universe is ordered yet violent, elegant yet vast and incomprehensible. Light bends along curved paths, galaxies rotate in arcs, and matter flows in response to unseen forces. Consciousness is small yet central, a witness to the interior's grand design. The singularity is both the origin and engine of all we perceive, encoding the universe's laws and structure. Humans, through observation, reflection, and understanding, engage directly with this architecture. The cosmos is alive with energy, information, and motion, preserving coherence, enabling evolution, and sustaining awareness. Within this framework, existence itself is a profound dialogue between observer and interior, perception and singularity, revealing a universe that is at once terrifying, magnificent, and infinitely mysterious.